means once we have a data in one hand, the algorithms will be that in other hand, and we will try to map that which algorithms actually suitable for this kind of a data for a particular map. That means the data, that means there are some distributions of their elements. Data consist of different elements or objects, and they are distributed in different natures. If you are aware with your statistics in your first year classes also, you may heard the name of the normal distribution, Gaussian distribution. There are binomial distributions. So these are actually the known distributions. So the known distributions, if your data elements can lie, you can easily identify the nature of your data segregation, and you can apply the known algorithms also. But in real situations, the data are not in actual distribution. So what machine learning can do? Machine learning will try to map in such a way so that this data will be means manipulated and will be distributed towards a known distribution so that we can apply our known algorithm. This is one of the ways that we people used to do with machine learning. Other ways is that once we have no kind of a mapping function to make it into a known distribution, then we try to uh, form some kind of a kernel function or some kind of a curve fitting algorithm so that it can segregate the classes among the data. It can identify a proper curve line out of the data. So these are some of the hypotheses that we people think behind the machine learning part. And the reason is that there are high amount or huge amount of data produced by the applicants. So we can receive the input data, use some statistical analysis to predict the output while updating the outputs as the new data becomes available. What it means that based on the data that we have that we have or that are available, we try to make a some kind of an algorithm to classify or segregate or to identify the data. Then when a new instance comes or new data elements comes, then we can easily predict that in which class it should belong to, and if which segregation it can belong to, which domain it can belong to, and like that. So the prediction is an important part of machine learning. So machine learning has different phases in way we try to make a machine able to learn something. So based on the input data, it tries to learn or capture the informations or feature statistics. Then suppose in case of teaching, in case of what I am trying to teach you, that I am giving you the lectures, but as a human being, as a student, you are trying to learn that whatever the important keywords or terms I am trying to utter. So those keywords actually are nothing but the features that are going into your mind to take that, okay, when the next class, when sir will say this term, that means this is the terminology of this term. So in that way, machine as a human being also will learn that based on the sample data or based on the training data, when it tries to learn something, then when a new instance comes, it can try to predict in which class it is close to belong to. So that is the machine learning part. Then when a new instance comes, it tries to identify that is. So there are training and testing or evaluation is the parts of the machine learning things. Then in broad sense, you may have heard the name of the artificial intelligence. Obviously AI, you have another subject also, open elective subject also, AI. There also you may learn that reasoning is there, uh, NLP is also there, planning is also there. So machine learning is also a part of AI. So in this decade, actually, machine learning and deep learning is becoming the most important part of artificial intelligence. And machine learning is composed of different types of algorithm. If we segregate or classify, then machine learning will be consist of several types of algorithms: supervised, unsupervised, reinforcement, and deep learning. So deep learning is the buzzword or is the keyword nowadays, and in order to make you properly understanding what are the difference between deep learning and machine learning is that suppose a object is given to you, and in case of machine learning, there is a human being as like us. So we are trying to extract the features first from the objects or from the data set. Then those features will be fed into the classification model or classification algorithm, and then it will take the decisions of the output, that in which class the object should belong to. But in case of deep learning, this human intervention is not there. So this is the first basic difference between deep learning and machine learning. So in case of machine learning, we have some kind of a human intervention by through we can identify the insights of the data, insights of the algorithm, how the algorithms are this given data and so on. But in deep learning, we can use it as a black box, because the advantage of deep learning is that nowadays a huge amount of infrastructure has been developed, not in India especially. I truly speaking, India and our state has no kind of infrastructure to use deep learning frameworks well. In abroad, they have high-end GPU, high-end machines where the deep learning algorithms can work much in a faster way. In case of India, there are very few IIT institutes. They have established the machines, but they do not know how to use it even. And these are the basic problems in Indian community, because the funds are not there, so we cannot invest the high end infrastructure. And for that purpose, deep learning is not very suitable till date in Indian scenario, because there is a huge amount of infrastructural cost is involved, but there is less human involvement is also there. Because in deep learning, it is a kind of a black box kind of a machine learning paradigm, where you can feed the data, the feature engineering or feature training or all of the machine learning things will be done by itself. Itself means by the algorithm itself, the feature extraction and classification, because it is a kind of a neural network based algorithms like our human brain. So all of the neurons will act accordingly, and then the algorithm will perform accordingly, and it will be decided that which is a car and which is a non-car, means we can classify accordingly. So human intervention is not there. So this is the first basic difference between machine learning and deep learning. Then, uh, ideal wise, if we can think that if the size of the data increases, the performance of the deep learning is even more in compared to the traditional machine learning algorithms. The idea is that these are data hungry algorithms. Deep learning is purely data hungry algorithms. So as much as data we have, the algorithms, the performance of the algorithms will be much better. So that means if we have enough data in machine learning also will boost its performance. In deep learning cases, if you have enough data, its performance is significantly improved, and it is drastically means you will get the desired result. But there is no human intervention, so it is very hard to detect that whether the algorithms are at all true or not. It's still a research question till date. So the categories in which machine learning actually classified is that we generally classified into two categories. One is unsupervised learning, another is supervised learning. So in case of unsupervised learning, we generally call it a clustering algorithm also. Unsupervised means there is no data set that is labeled. Labeled means we do not know its actual class. So whatever the instances are given to us, we do not know its classes well. So we will apply the algorithm in such a way so that it will segregate the data sets based on their features, and we can predict that which elements can be clubbed together to form a class. So that is a purely unsupervised way. We have no clue prior in our hand to detect that we have some kind of a labeled information or the train information. Whether in case of supervised learning, we will have the label data. Label data means we know that instance 1 belongs to class 1, instance 2 belongs to class 1, instance 3 belongs to class 3 or class 2, like that. So we know priorly that which instance belongs to which class. But in unsupervised clustering, we do not have that information. So supervised clustering generally is divided into two sets of problems. One is a classification types of problem, another is regression type of problem. So regression type of problems comes into the pictures where we cannot segregate the instances into proper classes. Like if your marks, like I will ask you to segregate your students' result based on the marks. So some of you got 98.9, some of you got 99.9, some of you got 98, some of you got 97.89. So it's a very close vicinity the marks you have obtained. So in that case, lot of people have lot of classes then. So how can we classify this kind of a data, right? Did you get my point? So if the class labels are very close to each other, say, then there is no meaning of classification, right? So these sort of problems we generally term it as regression type of problem, where the class instances are very close to each other based on their values, and the class labels cannot be determined literally. The class labels are actually determined by their values. Okay, so numeric values or numeric symbols. So in that case, actually, these sort of problems we generally try to map into the classification problem. The regression type of problem we generally or we finally try to perform it a classification type of problem to get some kind of output or results. And classification type of problem also can be mapped to a regression type of problem. So this is a kind of a vice versa problem. And we generally prefer to use some of the classifiers for regression types of problems and some of the classifiers especially for the classification type of problems, like need based neural networks, support vector machines are especially for classification types of problem that deals well actually. And in case of regression types of problems, decision trees, linear regression, logistic regression, ensemble methods, these algorithms are specially useful for regression to deal with the regression types of problem. And uh, I again tell that these two sort of problems can be converted into each other, and we generally prefer we learn that how we can solve these sort of problems, what are the problems are there, and so on. And another branch we have already mentioned that unsupervised, there is no label data, nothing is explained. We generally apply some kind of our own hypothetical algorithm or our means known algorithms or some traditional algorithms to identify at least how the elements can be grouped together. So these are actually the algorithms that are called clustering algorithms. These are purely unsupervised. Unsupervised means there is no supervision. There is no teacher. There is no training data. The students will learn automatically from the given input. There is no teacher will guide them to select, or no algorithms, no function, no kernel things are there which will guide them to identify that this you can classify the instances in that way. The design, the kernel functions, the mapping functions will be decided by the algorithm itself at the time of clustering. Okay. So supervised learning, the goal is to mapping function or to approximate the mapping functions from the input data to predict the output variable y, but we have a label data. Okay. All the AI systems that deals with the supervised learning that are given with a labeled correct label data. Next, classification and regression type of problems. We have already mentioned that classification like red, blue, disease, no disease, and like that. A regression type of problem where output variable is a real number or continuous value like dollars, weights, numerics, and so on. So in that case, how we can build a very good algorithm for that? It tries to predict the value for an input based on the past data. It's a real number that we have to classify. So the temperatures of for tomorrow, if we want to predict the temperature for the tomorrow, given the data of say 1 month, then it is a kind of a regression type of problem, and we'll deal with the regression type of classifier also. Then unsupervised cluster learning, we have already mentioned that there is no label is there that which class this element should belong to. Then it tries to identify from the algorithm that it can be of two classes. Okay, so how this kind of a algorithm will work, how we can segregate or separate the unlabeled data, we will learn the algorithms well in detail. So unsupervised algorithm also can be means segregated into two classes. One is called clustering. In clustering, we want to discover the inherent groupings of the data. That means we have no idea that how the data set are actually which elements are actually related to each other. We do not know the behavior of the elements or features of the elements so that we can group them each other. So clustering algorithms will help us to discover that. And association means we can identify some kind of rules. Rules means some kind of a if else type of rules which will entail us that how we can segregate the data. How, if this rule exists, then we can segregate the data, otherwise not, and like that. So association is nothing but your inference rules, your AI rules, your means if else rules that we want to develop for that. And there is another type of algorithm, reinforcement algorithms. I think some of you are already aware that it's a kind of a agent based algorithm where suppose if there is some kind of a reward is there, we can go into that directions. If there are penalization is there, we can go into the other directions, and in that way the agent based informations or output will help us to guide to go into the right direction to classify that. So reinforcement algorithms will also will also deal with. Then these are some of the practical applications areas in machine learning. Like in unsupervised algorithm, and for customer management or marketing based systems also. Then in unsupervised learning, there is also called dimensionality reduction. We will learn the latent semantic analysis LSA here. Sort of unsupervised algorithms will be used for discovery in case of civil and meaningful comparisons and so on. On the other way, supervised learning, there are two ways: classification and regression. Classification can be useful for image classification, especially it's a big domain. Then fraud detection, diagnosis in healthcare domain, customer cases also. In case of regression problems, the population growth, marketing, weather forecasting, means advertising also, lot of applications are there. In reinforcement algorithm are especially useful for games, AI based games, robot navigation, that how the robot will move into the correct direction or not, to predict the way of moving the robots. Then real time decision making and so on. So these are some of the vast applications of machine learning algorithms in any area that you people also may work. You may also identify in your domain how can you use machine learning. The frameworks that generally preferable to learn first, we generally prefer in this domain that for natural language processing, the Python toolkit for that. There are R languages also there, Rapid Miner is there, Wake Up platform is there. These are some of the known frameworks that you can explore your skills to learn machine learning more. Like Weka is a standard platform where you can just download the Weka, install in your machine, and you can see that if you feed some input and feed some classifiers also, the classifier algorithms are already embedded, so you can get the desired results and so on. So data and features, these are the two basic components of machine learning in everywhere. So we are the learners of machine learning, so we have the data and we have the algorithms, means data and features. So uh, so data can be in your Excel file, like an example. So this also data can be represented in a Weka format, in an attribute file format. So attribute or features, all of these terminologies you want to learn first, that attributes or features are actually the properties of any object. Like here, in case of math, physics, chemistry, biology, so these are actually your objects, and these are actually the values of your features. So in this way we can identify what are the objects and what are the features and what are the values for the features. Then based on those values we try to apply some good algorithms and to get the desired result. So all the machine learning algorithms will either deal with uh, labeled data or unlabeled data. If it is an unlabeled data, it's an unsupervised algorithm. It's a labeled data, that means we know the classes well, then it is a supervised algorithm. Data is always need to be pre-processed first, because if you want to collect the data from the Twitter, if you want to collect the data from the phones, from the HTML pages and your tables, your experimental data, it should be filtered first. Then uh, next task is that we have to identify the features from the data. So if it is a table, so we have to identify what will be the features. Features means the columns. The columns are actually the features of your data set, and rows are actually the instances or the objects or the elements of your data set. So the data set, once you have a data set, that means you consider that the elements which will be represented in terms of rows, and the features will be represented in terms of columns. So the values of the features will be in terms of the columns, and rows will be indicated as your elements or your objects. So each of the elements have some kind of a features and their corresponding values. So our objective is to map a good algorithm to identify suitable features. The problem is that there may be a millions and trillions of features for a particular elements. Okay, in some data, in some experiments, you will get that for a particular element huge amount of features are possible. So there are techniques are also there too. We generally call it a dimensionality reduction techniques, where we reduce the dimensionality from millions to thousand. That means we are reducing the dimensions of the features to a reasonable one, so that we can apply some standard machine learning or deep learning algorithms for that. We can identify that which are actually your important features. So this sort of analysis are actually called the feature studies or feature engineering, or the principal component analysis, LSA, latent semantic analysis. A lot of unsupervised algorithms are available too for this dimensionality reduction cases. Okay, I think I am just trying to see. Okay, there are a lot of things are there. We cannot discuss it today because already there are a lot of things we have discussed. So, from features, from data, you have got some knowledge. And next class onwards, we'll try to means make you more understanding in your skills, that how these features are useful, what we generally call features, and how we can deal with the features, and how can we apply the machine learning algorithms to deal with the features. And then we start with some kind of a detailed algorithms and further applications. Okay, so today I would like to stop here. Maybe this will be huge for a single class. So you can now raise your and see if you have anything to say in your mind, any observations or any feelings, then otherwise we can stop, no problem. So I'm just stop presenting here, or maybe if you can ask, then I can deal with that. So have you any question from that, or how many of you are quite aware of the machine learning? Means I know that some of you do not hesitate, please raise your hand. That will actually help us to discuss more and in detail, and with in a conversational way we can ask you and you can ask me, so that it will be a interactive way we can learn a lot. So how many of you have heard the names and some of the techniques, and After completing one complete slide, then only I can share, because it is a big slide. I cannot share in between. So once it is completed, I will share it on that day particularly. And so just tell me very frank that you have used some machine learning. Maybe you have explored in your domain or something. You have made any one internship in one cases, and you have applied that machine learning. So you can share it if you have any kind of a doubt or field or anything. How many of you are aware of the machine learning or terminology at least? I hope you have. Please raise the hand so that it will be helpful for me also. Chamrit, okay. Then any others? Oishik, okay. Others? Don't feel. I'll not ask any question or anything. You just raise your hands that you're quite interested, so that I'll get know that uh, you want the things, and okay, very good. Okay, Shamritho. So uh, most of them, yeah, one, two, three, four, five, six, seven, eight people have already raised their hand. So okay, more hands are coming now. So can anyone say means Shubhrashil also can tell that in where you have used this one, or you have just explored these things? Maybe a bit, one or two lines.
Sir, I'm just learning like the things, and I'm
Okay,
trying to do image classification project.
okay, very good. And Navneet, okay, then Aishik, okay, then Shamridho. He has raised the first hand, so
Yes. So actually, I started exploring these things right from my first year, and I got motivated from the seniors of my department. They have worked on like very.
could you be a bit loud?
Yeah,
Because
am I audible? Hello.
yes, now you are audible.
Yeah. So
Yes,
actually,
you are
I
audible.
yeah. So I got to know about the machine learning thing like right from the first year only. I started to explore all those things, and
Mhm.
many of the seniors of my department also worked on image classification, deep learning. So
Hmm.
like from them also I got several insights, and
Hmm.
actually I worked under a deep learning project under Professor Ram Sarkar. So
Okay, okay, okay. Then you are associated with our department also already.
yeah, yeah, actually
Okay, you are electronics, from
no,
electronics,
I am from metallurgy.
metallurgy. Okay. Then others on Raisha. Is it? I'm correcting the pronunciation. I don't know. Raisa, right?
Yes, sir. Yes, sir. So actually, I had
So,
studied some basic machine learning algorithms and supervised learning, unsupervised learning, and some of the algorithms associated with the same. I tried to help one of my I tried working for one of my senior. He was working on signal processing. So in
okay,
using the various optimization algorithms for getting the minima and maxima in modeling and observing the signals. And I was also working with Professor Nibaran sir, but I did not work for a long time because I had some other I changed and I was doing coding for some time, so it got disconnected.
okay. Very good. That means you are also associated. You are from which department?
Electrical.
Electrical. Okay. So already you, some of you have some kind of a feel on that. Maybe you will learn a lot from this course, and you will